The first section we're going to look at is section 2.1, and 2.1 covers scientific notation. Our aim for this section is to show how very long numbers can be expressed as the product of a number between 1 and 10 and a power of 10. So this really looks at three different parts of this definition and what it looks like to have a number written in scientific notation. I'm sure we've seen all of this before, but when you're taking a number and putting it into scientific notation, it's very important to observe the three different parts that we're going to talk about. So our aim, again, is to show how very long numbers can be expressed as the product of a number between 1 and 10 and a power of 10. So we're going to talk about what that looks like with this first number. So this number is 684 billion, but when we write this number, we don't want to write all of the zeros that go along with it. We want to save ourselves some time. So is there anything wrong with the number? No, not necessarily. It's just a number that we want to represent in a slightly different way. Is there a better way to write it? Yes, because we're able to write this using scientific notation in a way that cuts out all of those extra digits, cuts out all of the zeros. The zeros are still there, but when we write this number using scientific notation, it simplifies the number. Scientific notation is a way to concisely report long numbers as the product of a number and a power of 10. Now, a lot of people mistake this word for large. They will say it's a way to report very large numbers. But remember, large numbers can also refer to, or can only refer to numbers greater than one. That's what we would refer to as a large number. If we're talking about a very small number, very small numbers can also go out to a number of decimal places. So it's not necessarily only large numbers that we're reporting, but it's long numbers. It's numbers with a lot of digits attached to them. So we want to talk about what each of these pieces mean. And this first part where we're looking at a product of a number, we're using scientific notation to start us off by saying that number is between 1 and 10. Now, scientific notation can be written for numbers that are not between 1 and 10. We refer to standard scientific notation as the base number being between 1 and 10. So a number can be written in scientific notation without having the base number between 1 and 10. Specifically, standard scientific notation has that number, that very first number, written between 1 and 10. And that's what we're going to be using pretty much exclusively, is numbers between 1 and 10, or standard scientific notation. A little talk about exponents or powers of 10. I'm sure we've all seen this before, so this should be review for most of us. But what we're looking at is the exponent, the power of 10, this number on the top and what it represents. And there are a couple of different ways to look at it. But in general, numbers greater than 1 will have a positive exponent. So we can think of every number as the number 1. Every number written in scientific notation that has 10 to a power will start with the decimal point in the ones place. Now that exponent tells us how many places we are moving that decimal point. And we'll get to which direction we're moving it in a minute. But if my exponent is 0, you can see that that decimal point stays in that location. If my power of 10 or my exponent is 1, you can see that I have started from this location and moved it one place to the right. If my exponent is 2, again, starting from this location, moving it 2 places to the right. And the same if my exponent is 3, starting it here and moving it over 3 spaces. You can also look at this as how many times is 10 multiplied by itself. So, for example, 10 to the second power means 10 times 10. And we know that 10 times 10 is 100. So that's where the converting the power of 10 turning it into a decimal number. Now, notice that all of these exponents are positive because the number is always getting bigger. Numbers greater than 1 have positive exponents. Numbers less than 1, or decimal numbers, will have negative exponents. So we see the same pattern here. 10 to the 0, anything to the 0 is 1. I have -1, and what this tells me is that I was starting with a decimal in the ones place, and I moved it one space, one decimal place. Notice I did not make the number larger with this movement. I actually moved it to the left. And in doing that, I made the number smaller. I went from 1 to 0.1. Now looking at 10 to the negative second, again, if I'm starting the decimal point in the ones place, I moved it to the left in order to make this number smaller, 2 places. And then the same thing happened with the -3. Starting with a decimal point in the ones place, the -3 tells me that I'm moving it over 1, 2, 3 places to the left. And again, you can look at this like how many times are you multiplying 10 by itself? And we looked at 10 to the second in the previous part, but if we're looking at 10 to the negative second, 10 to the second meant 100. 10 to the negative second means 100th, or 1 over 100. So these are all the different ways to look at exponents. This is one way, just one way to think about how an exponent or a power of 10 will work in terms of scientific notation. But we're going to look at another way. We're going to look at converting the number 93 million to scientific notation. Again, nothing wrong with this number, but we just want to make it a little bit easier to read. So our first step, knowing that we're always going to be using standard scientific notation, is to identify the number that we're talking about that's between 1 and 10. And this number is 9.3. We're looking at digits that aren't 0 to represent a number between 1 and 10. So my only options are 0.93, 9.3, and 93. These are the ones I have to choose from. Only one of these is a number that's actually between 1 and 10, and it's 9.3. So that's the number that I'm going to be starting with here. We're going to represent a product. And we know that in mathematical terms, a product is another word for the answer to a multiplication problem. So that's the second part of our scientific notation term. The first, a number between 1 and 10. The second means we're representing a product. We're going to use base 10. That means that number we're multiplying by is 10. Now we just have to figure out what is our exponent. We have our 10, we need to find the power of 10, and remember that power of 10 tells us how many times we are moving the decimal point from the number between 1 and 10. So what that looks like is I am starting from this location, from the number 9.3, because that's what I've identified as my number between 1 and 10. Now, from here, I want to figure out how many times I need to move the decimal point to get this number to look like this one. How can I make one number look like another? I have to move the decimal point a certain number of times, and we can see here that the number we're trying to get to, or the number we're trying to identify, is larger than 1. So that means my exponent is now going to be positive. So I'm going to move my exponent to the right. We said positive exponents move the decimal point to the right. 1, 2, 3, 4, 5, 6, 7 times. So therefore, my exponent is 7. So this is a number that has an exponent that is greater than 1 to show that we are moving, or positive exponent to show that we are moving the decimal point to the right to make the number larger. So my final answer is 9.3 times 10 to the 7th. The next example looks at a number that's less than 1, 0.000067. Again, nothing wrong with this number. We just want to write it a little bit more concisely. We want to clean it up a little bit to get those zeros out of the number. We follow the same steps, whether the number is greater than 1 or less than 1. We want to identify the number between 1 and 10. So I have 3 options looking at the numbers that aren't 0. I have 0.67, 6.7, or 67. So there's only one number that fits that criteria, being between 1 and 10, and that's 6.7. So that's what I start with. Our next step is to represent that we have a product. So remember, a product means the answer to a multiplication problem. And then we use base 10, and base 10 is what allows us to move that decimal point. Every time I move that decimal point, it's one more factor of 10. So 6.7 times 10, and now we need to identify the correct exponent. Again, we're starting from our location here, so we want this number to look like this one. So starting from the point at 6.7, this time we're moving the decimal point to the left. We are making this number smaller. So what we're looking at is 1, 2, 3, 4, 5, moving the decimal point 5 places to the left. To the left means we have a negative exponent. So this term in scientific notation, 6.7 times 10 to the negative fifth, told us that we are moving the decimal point 5 places to the left. That's what negative 5 refers to. Now, converting from scientific notation, we get the same information from that exponent. That exponent is telling us if the number is large or small, and it's telling us how many places we're moving the decimal point. So this number, 8.2 times 10 to the fourth. We start at the decimal point, and the decimal point is here at 8.2. From here, we're going to move the decimal point as indicated by the exponent. Here we have a positive exponent, so that means we are moving the decimal point in order to make this number larger. Positive exponents move the decimal to the right, which is what indicates a large number. 1, 2, 3, 4 places, as indicated by the power of 4. So what do we do now that we've moved the decimal point to this location right here? We're going to fill in zeros, add zeros to fill in to make that number complete. So we are adding 3 zeros to this number. Our final answer is 82,000. So this would be if I'm asking you to write an ordinary decimal number from a number that's already written in scientific notation or standard scientific notation. So this is another example. This number is smaller. We can see that we have a negative exponent here. So if we're starting with 3.6 times 10 to the negative fourth, we use the same process. We start at the decimal point that is between the numbers 3 and 6. This time we have a negative 4 for a power of 10. So what we're doing here is moving the decimal point 4 places to the left. We want this number to end up being smaller. If we moved it to the right, that number would end up being really large, but the negative tells us that that number is actually going to be very small. So you're going to move the decimal point as indicated by the exponent. This time we have a negative exponent that will move the decimal point to the left. 1, 2, 3, 4 spaces to the left. And again, we use the same process. You fill that in with zeros. So we have 3 zeros. Our decimal point now is right here. So that means our final answer is 0.00036.
Please pause your video, take a minute to practice with these problems, resume the video, and we'll look at the answers.
We are asked to turn each of these numbers into standard scientific notation. Remember, that involves a series of steps. The first one being identifying a number between 1 and 10. For the first number, that number would be 2.38. We have to multiply that number times 10, and remember that times 10 tells us we're moving a decimal point. We need to decide if that power of 10 is going to be positive or negative. In this case, the number is greater than 1, so that's going to be a positive exponent. We're going to go back to the original number and start where we identified our decimal points beginning, and then we'll move that 1, 2, 3, 4, 5 places to the right. So our final answer is 2.38 times 10 to the fifth. For number 2, our number between 1 and 10 is 4.3. We are multiplying that times 10 to a negative exponent this time because that number is less than 1. So starting at the number 4.3, we're moving that 1, 2, 3 places to the left. 4.3 times 10 to the negative third. For the third number, the number between 1 and 10 is 1.5. We're multiplying that times 10 to a power. In this case, that power or that exponent is positive because the number is greater than 1. Starting at 1.5, 1, 2, 3, 4, 5, 6. 1.5 times 10 to the 6th. And in the last one, our number between 1 and 10 is 8.9. Multiplying that times 10 to a negative power. This time the number is less than 1. Starting at 8.9, we're moving that to the left 2 places. 8.9 times 10 to the negative second.